So we're going to talk today about areas again, and the idea of an integral being the area. To this point, we've talked about it as being an area between a curve and the x-axis. So we're going to introduce something a little different. Now we're going to talk about finding the area between two functions, between two graphs. So the area represented by the letter A of a region bounded by the curves y equals f of x and y equals g of x, and the lines x equals a, x equals b, where f and g are continuous and f is always greater than or equal to g. Is the integral from a to b of f of x minus g of x dx. Okay, so no more making fun of Ben, he's here now. All right. So we could have a function like this. Find the area of the region bounded above by y equals e to the x, below by y equals x, and bounded on the sides by x equals 0 and x equals 1. All right, so x equals 0 would be our A, x equals 1 would be our B, our upper function, and you won't always be told which is the upper function and which is the lower function. But it's pretty easy to figure out. If you're not told, just pick a number in between A and B and plug it in. Whichever one gives you the larger value, that's your f, that's your upper function. Whichever gives you the lower value, that's your g. So we're going to take the integral. from 0 to 1. E to the x minus x dx. So we call this finding the area between the two functions. And really what we're doing is we're finding the area under e to the x and subtracting the area under x. All right, so we're finding the whole area and then subtracting off that bottom part. All right. Do we know the integral of e to the x? All right, e to the x, its integral is e to the x. Yeah, there we go. And x, or x to the first power, if we use our power rule, we add 1 to the power. And then either divide by that new power or multiply by its reciprocal. I'm a multiplication kind of guy, so I would put 1/2 x squared. And we're going to evaluate from 0 to 1. So we would get e to the first. One thing to be aware of on the AP exam, they might just write e without an exponent, just to, the understanding that if there's no exponent, it's a 1. Minus 1/2 times 1 squared. Minus e to the 0 minus 1/2 times 0 squared. So e to the first minus 1/2 e to the 0, that's 1. And 1/2 times 0 squared is still 0. So that's okay. And I wouldn't give an estimate. I would leave it in that fraction form. If it was on the calculator portion of the AP exam, they would have it as a decimal, more than likely. That's that. Questions on that example? It's a good lesson to come back from on spring break. Lots of good review stuff. All right, find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. I even gave you a graph. Look at that. How nice am I? All right, don't answer, please. That's all right. So what don't we have here that we had in the first example? Yeah, the bounding values for X, right? So I think maybe, hopefully, you can see that we have 2 points of intersection. Those become our boundaries then. So we need to find where the 2 graphs intersect. So the easiest way to do that is plug them into your calculator and use the intersect. No, I think that's actually harder than doing the algebra. Set the 2 functions equal to each other. Solve for X. So if I add X squared to both sides and subtract 2X from both sides, I'm going to take my integral from 0 to 1. On that interval from 0 to 1, which function is larger? And don't say this one. It's that one, but what is that? What is the function for that?
Y equals 2x.
There you go. Exactly. Right. It's a negative parabola because it's opening downward. So that's our upper function. That's the one we're going to do first. That's our f. And then we're going to subtract our other function, which is x squared. Again, I would, in this case, simplify a little bit. We've got that minus x squared minus another x squared. That's minus 2. X squared plus 2x. Couple of power rule integrals here. So that x squared becomes x cubed, but we divide by 3 then. The x becomes x squared, and then we divide by 2. Well, 2 divided by 2 is 1, so we're good there. If I plug in 1, and plug in 0, I like integrals of polynomials when I have 0 as one of my limits. Makes things a lot easier. So on a problem like this, if you forgot or had the wrong function as your larger function, the only difference would be your answer would be negative. So if you do a problem finding the area between two functions and get a negative answer, more than likely, you just had the functions in the wrong order. So you took the smaller minus the larger instead of the larger minus the smaller. Right. So the other thing that can happen is instead of having y equals a function of x and taking the integral, it might be easier to have our equations x equals a function of y. And then instead of f being larger than g, which it still is, but in terms of y, our function f would always be to the right of our function g. The nice thing is the variable that we use as we integrate doesn't affect our integral at all. Other than we're going to have y's and dy's rather than x's and dx's. We could use any variable and take the integral and we'd be okay. All right, so find the area enclosed by the line y equals x plus 1 and the parabola y squared equals 2x plus 6. So the problem becomes this y squared. Right? And I know what you're thinking, Mr. Gingrich, why don't we just solve it for y? Right? So what would we do if we wanted to solve that for y? Take the square root. And when we introduce the square root into the problem, what do we also have to include?
Positive and negative.
Plus and minus, correct. Correct. So we could. It just will make the problem a little bit more difficult to do. So to graph this, You know, I'd pick maybe values for y and just see what happens. So like 0. I believe if I plug 0 in, I get -3 for x. And my, oh, I know what I did wrong. And then if I plug in 1, 2x plus 6 equals 1. Two x would equal -5. X would equal -2.5. Oops. Why doesn't that seem right? Oh, I know why it doesn't seem, okay. So when y is 1, x is 2.5. You know, just picking another value like let y equal 2. So we get 4 equals 2x plus 6. So x would be -1 when y is 2 and when y is -2. And I think you can see what's going on here. So in this case, our parabola for part of the graph is below the line, but for this part here, the parabola is above the parabola and the line isn't kind of affecting the area. So if I do solve these both for x, I would get those two functions, x equals y plus 1 and 1/2 y squared minus 3 equals x, or x equals 1/2 y squared minus 3. And I still need to find my points of intersection. Personally, I don't like that 1/2 in front of my y squared, so I'm going to multiply everything by 2 just to make it a little bit easier. You know, my little pea brain after spring break isn't going to be able to factor that if there's a 1/2. Just make sure you multiply everything by 2. And now, oh, now I think I can factor this if I move everything over. makes me think my graph is way wrong. What did I know what I did wrong. You silly guys. Anyone see what I did wrong?
Yeah, you did negative X.
I did negative slope instead of positive slope, yeah. Yell at me when I do that stuff. There we go. It's a little bit better. Which function is to the right of the other? And when I say that, I mean specifically in that Reese, I'm talking about right here. Which one is to the right? Ooh, okay, let's take and plug a value. And what is a number between -2 and 4?
0.
0 would be an easy one, right? So I plug 0 in for y, I get 1 and -3. Which value is larger? 1. Yeah. So our rightmost function is our linear y plus 1. So we're going to integrate. And again, if you're not sure, one thing you could do is just pick one and take the integral. And if you get a negative answer, then more than likely all that happened is you chose the smaller function instead of the larger function first. Again, I would rewrite this. It looked almost like a 3. That should be a 2. All right, taking the integral. Y cubed, and I'm going to divide by 3 or multiply by 1/3. I already have that -1/2 there. So that's going to give me -1/6. And 1/2 y squared plus 4y. Plug in the 4. Trying to make my 4's not look like y's. And plug in -2. One thing that I like to do when I have fractions is leave them until I'm done combining like terms and doing things like that. So 4 cubed is 64, so I'd have negative 64 over 6. Okay, here's the exception. I know 4 squared is 16 and half of 16 is 8. And 4 times 4 is 16. Negative 2 cubed is negative 8 times negative 1/6 is 8/6. Positive because we've multiplied two negative numbers. 1/2 of negative 2 squared, negative 2 squared is positive 4. Half of 4 is 2. Negative 2 times 4 is negative 8. So what happens, my negative 64 over 6 minus 8 over 6 gives me negative 72 over 6, which is kind of nice because that's negative 12. Here I'd have 24. Minus negative 6. Doesn't always work out with fractions that way, but in this case, not worrying about fractions until the end actually ends up giving you a pretty easy answer. Yes, ma'am.
Did you have to say like square units?
The only time you would is if it was an application type problem. But no, in this case, you're just, the area is 18 and that's enough.
Okay. On the test, would they tell us like expressing units?
A lot of times they will say label with proper units. And then if I've seen in problems where having that unit, the correct unit, is worth one of the 9 points on a free response question. I've also seen where it's worth a point in each section. So there are times, and usually that has to do more with distance, velocity, and acceleration. So just as a reminder, if you're not given endpoints, limits for your integral, set your functions equal to each other and solve. If you're only given one, then the two functions only intersect once. And again, find that other point of intersection for your second limit. And then obviously, if you're given both, you have them both and you're ready to go.